the packet on your desk should help you with this. You need to figure out how are these similar, alike, how are they different, using all the different formats and formulas and different variations you see on that front page. So take a couple minutes and think about that, and then we'll talk about with any similarities, differences. They can be obvious ones or something more specific to what we're doing. Say that one more time. Okay. Both have a y. Both are equal to. Okay. They're both what? Direct or inverse? So they're both not inverse. One is, the other one is not. Which one is inverse? This one? X has to be in the denominator. So this one is inverse, which makes the other one direct. This can be rewritten, which is why it's direct. What else? How else are these the same or similar? They both have a y, they both have an equals. What else do they both have? An x and a 2. Okay. What is this in general? Okay, so they both have fractions. Not what I was looking for, but they do both have fractions. This is some sort of equation. They're both equations. If I asked you to find the k value of this inverse variation equation, what would that be? What would the k value of the direct be? 1/2. That's about all that we can find, unless we have anything else. So this was just to refresh our minds of what inverse and direct look like, because we're going to be dealing with a lot of those today. No? Okay. Gabriel, come up. So in the notes that you have, skip till you see this page. Because we did some of the first 2 pages. You can look on this class recording on Canvas to find out. So the reason is joint and combine. Some of them combine, it uses direct and inverse in the same problem. Joint is something a little different, but we'll talk about that. So we need to remember what direct and inverse look like in order to do these. Also, change this word to inverse, please. Because that was written twice. Okay. I'm going to rewrite our direct and inverse. I'm going to rewrite our direct and inverse up here, just so we aren't flipping back and forth. So direct, y equals kx. Inverse, y equals k over x. In this part, we're just rewriting these words into the format, the equation. So y varies directly. So this is like the problems we were doing before break. Whatever comes first is going to be like your equals. So y equals varies directly. So it's going to look like this, but instead of kx, it's going to be kx squared. So it'll be similar. How do you think we would write y varies inversely with the square of x, based on what the inverse looks like and what we just did? So not square root, but square. But how would that look? How would we write it? K over x squared. Y equals k over x squared. So y varies inversely. That's going to be your y equals the square of k. Sorry, with the square of x. The k is implied. You always need a k. If you're missing k, you kind of miss the whole point. Right? Now our variables change, and we're using the word jointly. Jointly is like direct. It just means you're multiplying multiple things. So z varies. That's going to be a z equals. Varies jointly. Everything is being multiplied together with x and y. So we need a k in there somewhere, and then you just put x and y next to it. This one is taking what we just did and the inverse and combining them. Anyone want to guess how this might look? What would this start with? Let's start with z. So z equals kxy all over w. So varies jointly with x and y. All of that is being multiplied with k. The inversely with w, we're dividing. So when you see inversely, you should be dividing. Jointly or directly, you're multiplying.
It's just a question because it wasn't here. For why'd you put k when it wasn't actually the same?
So if there's a constant k in these, no matter what, you're trying to find that constant k, and that helps you with the equation. It's just part of the equation. So it will always be there, even though it doesn't mention it. Right? Z varies directly with x and inversely with the product of w and y. Anyone want to take a guess as to how we would write that one? Z equals, we said kx, that part's right, over, what did we say? So directly with, you're multiplying the k and the x, and inversely with, everything else is being divided. The product of w and y are being multiplied together, but divided to everything. So being able to write the equation is going to help us set up the equation and then solve. Questions on those so far? So since it's been a while, we're going to do a good amount of these. So let's start with 1. Variable m varies directly with p. Before we do anything else, let's set up this equation. What would that look like? Think about what we just did. How would this part be set up? M equals. Missing something. K. So always set up your equation first. Then we are given 2 numbers. You can put those 2 numbers in, solve for k. So in this case, to solve for k, we would divide. And whatever that is, we give you k. What is that? If you don't have a calculator, go grab one. Find m when p equals 16. So we're going to go back and use our original equation, put in what we know, our k and our p, answer, we're done. Questions so far? So we did direct already. This is just with different variables. We did inversely as well, but different variables, so let's do that one. R varies inversely with the variable t. How would we set that up? R equals k over t. So then put in the numbers you know, 168 and 24. To solve for k in this case, what would we do? Multiply the 24 on both sides. So when multiply that, how did you get?
40, 32.
40, 32. So we have k. Now it's asking, find r when t equals 30. So back in our equation, we don't know r, so that's going to stay r. We know k, and now we know t. Divide that. Figure out what you get.
One 134.4.
130 what?
134.4.
Questions on that one? Right, look on the back of this page. One more and see where we are with them. Number 3, variable y varies jointly with p and q. What would that look like? Not what jointly means. Y equals k p q. They give us y, p, and q. So put in all of those numbers.
Yo, can I get that?
Yeah, I got you. I was using my phone.
And then whether you want to multiply this first and then divide, or divide and then simplify it all together is really up to you. What is 12 times 8? So then k would equal, I said 84 and you guys said 96 and it's, okay, that's not what I was What is k? And then we'll stop there. 1.5. And then when we get back, we'll do the other part. So we found k. Now we're going to use our original equation with the numbers given. We have to find y. We have p equals 15, q equals 25, and k. So we don't know y, so that stays the variable. K is now 1.5. P is now 15. Q is now 25. Multiply all of those together. Figure out what y is. So 270.
I got something different.
You got that? So it should be that. 563.5. some applications on the next page. But let's do 5. So variable t varies directly with the square of m. How would we set that up? T equals k m squared. I almost said that wrong. It varies directly, so we're multiplying. Then we have if t equals 8 and m equals 2, so put that in and find k. So 8 equals, we don't know k, we know m is 2 squared. So 2 squared would give us 4. And we can divide both sides by 4. So that k equals 2. Then for the last part, find t when m equals 4. Use that same equation. We don't know t, leave that as a variable. K is now 2, and m is 4. But it's still squared, so don't forget that part. You can put that all in your calculator at once. You can square the 4, then multiply. It's up to you. What would t be? 32. So if you did that all at once, that would be 2 times 4 squared. Or you could do 4 squared and then multiply it by 2.
So for the second part, you wouldn't have to have a k there.
So you already did it,
Oh,
and you're putting that k back in.
is this all you have to do to show the answer?
Right. Now we're going to do some application problems. So go to the next page. Some of these are strictly varies directly. Some of them are strictly varies inversely. Some of them are a mixture. Some are jointly. You just have to pay attention to the words. So we're going to skip 1 and jump to number 2. So let's read through it first. In building a brick wall, the amount of time it takes to complete the wall varies directly with the number of bricks in the wall and varies inversely with the number of bricklayers that are working together. A wall contains 1,200 bricks using 3 bricklayers. Takes 18 hours to build. How long would it take to build a wall of 4,500 bricks if 5 bricklayers worked on it? Say that back in the class. What's important here? Okay. So 1,200 bricks, 4,500 bricks, 3 bricklayers, 5 bricklayers, 18 hours. Any other things important? Varies inversely. And
How long would it take?
varies directly. And how long would it take? So we know what we're looking for. The variables you choose here are completely up to you. You can make them match. You just have to say what is what. So let's say whatever comes before this, let's call it y, just so that we're still doing the same thing. The amount of time would be y. With the number of bricks, call that x. And then varies inversely with the number of bricklayers, so let's call it z. You could call it a, n, and b, or t, b, and l, whatever you want. They just have to be 3 different variables. So before we get into the numbers part, let's set this up. The amount of time varies directly with the number of bricks and varies inversely with the number of bricklayers. How would we set that equation up? Y equals kx. What about the z? Over z. So varies directly, y equals kx, and varies inversely with the number of bricklayers, c. So it looks complex because it's a bunch of words. But when you figure out what those are, put variables to them, it's not that bad. So now we have our equation. Now we're going to use the first set of numbers to find our k value. Color code. So number of bricks is x, brick layers is z, time is y. So 18 equals, we don't know k, 1,203. So after you set up your equation, then you have to keep the variables straight. Don't mix them up. Don't put z where y is, because then your equation is wrong. You can either divide these and then divide them again, or get rid of 3 and then divide. How you do that, there's a bunch of different ways. So let's say we divided first. What would that give us? 400. And then divide again, solve for k. It's going to be some fraction or decimal. If it's a nice decimal, it's fine. 0.45.
0.45.
What would that be as a simplified fraction? So if we did it as alpha y equals instead, it would leave it as a fraction.
It's 0.045. I said that.
0.045. 49200. Sure. Equals k. So that's part of it. Then we have to figure out how long. So how long is going to be which variable are we looking for? Y. Time. So we're looking for y. We don't know it. We have our k. You can put it as either or. It doesn't matter. I'll use a decimal since it's a nice decimal. Our new x is 4,500. And our new z is 5. You can put that all in all at once. You could multiply then divide. It's up to you. Figure out what y is.
40.5.
40.5. Is that what we all got? Right. And because it's a real life problem, we have to take into account our units, hours. You said 40.5.
Mm-hmm.
So 40.5 hours. So the work is really the same. We just have to piece together, okay, what is this? What variable would this be? Where would this go? How would I set this up? Once you get that part, then the rest is the same. Do we have any questions on this one before we do another? We're going to do another one where it varies directly and then varies inversely, number 3. So let's read through that one. A video store rents DVDs and the weekly total number varies directly with the total inventory and varies inversely with the cost of each rental tape. The store in Acme, New York last week rented a total of 3,000 DVDs when its inventory was 9,600 and the cost per rental was $2.40. If its inventory does not change, what would be the effect on the weekly total number of increasing the cost per rental to $3? What's important here?
Varies directly.
I heard multiple things. Varies directly, I heard, and what did you think? Weekly total numbers. Is what we're looking for. What else is important?
3,000 DVDs.
Okay.
3,600.
Inversely, the 9,600.
Cost per run.
And the cost per run.
I'm gonna do different colors.
So you can use the same variables as the last one, or you can change them, up to you. So whatever comes before varies directly, the weekly total number, that's going to be your Y. Whatever comes after is going to be your X, your total inventory. And then varies inversely with the cost of each rental date, your Z, or whatever else you want to call that. So when we set it up, it's going to look the same as the last one. Y equals kx over z. So then we're going to use the three numbers they gave us, the 3,000, the 9,600, the 240, to find our k. DVDs equal, that's Y, that's the wrong color. Inventory is X, and then the cost is Z. Relabeling them, the numbers, especially when there's multiple, will help you figure out which one is which, so you don't confuse them. So we have 3,000 equals K times 9,600 all over 240. Did you make a pass? Sorry. Divide that, tell me what you get. You need me to make it.
Yeah.
So 9,600 divided by 2.4. Or 2.4 is
4,000?
Say that number one more time.
4,000?
So that will be all around 4,000. Right, and then divide 3,000 by 4,000. K equals
0.75.
0.75 or 3/4, either or. Alright, so now in our last part, if the inventory does not change, that means whatever it was is going to be the same. We're looking for the weekly total, so we're looking for which variable. Y. And then we have the cost and it's going to change. So we're looking for Y. We know our K value is 0.75 or 3/4. Our X has not changed, it's still 9,600. But our cost is now 3. Figure out what Y is.
2,400.
2,400 DVDs. So these, take them step by step. Don't rush if you don't have to. Make sure you're reading things, putting things together clearly. Do we have any questions on these two so far? the remaining problems. So 4 is like the 2 we just did, so we're going to do that one. 5 is different, and 6 is similar to the ones we just did. So we'll do 5. And then I'll see if we can find the jointly word problem, and then we'll be done. So for number 5, a ball is dropped from a window of a building. The distance it falls varies directly with the square of the time it falls. If a ball can fall 8 feet in 0.5 seconds, how far will it fall if it takes 2.5 seconds for it to hit the ground? What's important?
Varies directly.
Very directly. What else?
Square.
The square is important.
8 feet and 0.5. Or 0.5 seconds.
And 0.5. What are we looking for?
How far it will fall.
2.5 and how far it'll fall. Right. So in this, we only have 2 things happening. Whatever comes before the words varies directly and whatever comes after. You can use just 2 variables, call them y and x, whatever you want. Whatever comes before is going to be your y, the distance. So 8 feet would be your y. And then whatever comes after would be your x. I didn't really highlight. So the 0.5, the 2.5 would go with the x. So that means we're looking for which variable?
X.
We're looking for how far, so not the time, so that would be y. So if the distance varies directly with the square of the time it falls, how would we set that up? Y equals kx squared. Right. So same as before, take the 2 numbers you have for x and for y, put those in, find k. So we have 8 equals, we don't know k, but we know our x is 0.5, and we're going to square it. 0.5 squared is what?
0.25.
0.25. And then if we divide both sides by 0.25, k is what? 52. 32. So now we have k. We're going to use our original equation and the number we're given to find y. We don't know y, that stays y. Our k is 32. Our x is now 2.5 and we're squaring it. What is y?
200.
200 what? Feet. Do you have any questions on this one? You're next in line after Abia. on the very last page, number 10, and that'll be the last one you do. That way you'll see one of each kind or type of problem. So for number 10, for a given interest rate, simple interest varies jointly as principal and time. If $2,000 left in an account for 4 years earns interest of $320, how much interest would be earned if you deposit $5,000 for 7 years? What's important there? Varies jointly.
2,000.
2,000.
4 years.
4 years.
320.
320.
How much interest would be earned?
How much interest?
5,000 for 7 years.
5,000 for 7 years. Alright, so whatever comes before very shortly, we're going to call that the interest y. And then the two things after, x and z. So principal, x, time, z, but it doesn't matter. You could switch those. So every time you see something about interest, that's going to be your y. Every time you see something about principal, that's amounts of money. So the 2,000 and 5,000, those are principal amounts. And then time would be your number of years. What variable are we looking for at the end? Alright, so let's set up our original. For a given interest rate, simple interest varies jointly as principal and time. What would that look like? Y equals kx z. So in our original, we have 2,000 for x, 4 for z, and 320 for y. There may not be a whole lot of space. You may need to use the bottom space, or I just wrote really good. So 320 equals k. We don't know what k is yet. Times 2,000 times 4. We multiply 2,004, that would give us 8,000. And then divide 320 by 8,000. .04. Or if you wanted to leave that as a decimal, as a fraction, 1/25. So some of these you may need to leave as a fraction, that's why I keep doing that, especially if it's a repeating decimal. Okay, so now we are looking for y. I'm putting this up here because I'm running this space. We know our k value is 0.04. Our x is 5,000. And our z is 7. Multiply those all together. $1,400. Is that what you got? 1400 what? What is interest measured in hundreds of dollars? Do we have any questions on that last one? So, Friday, we're going to review, and then you guys are going to take your quiz. So I would recommend, this will help you with the other two. It's direct, all things inverse, and then combine and join variation. So keep working in these notes. Practice the delta math test due on Friday. Let me know what questions you have. Use this time wisely. Abir, you can make your pass.